In this problem, we have two bags. Bag A has 3 chips labeled 1, 3, and 5. Bag B has 3 chips labeled 2, 4, and 6. So one bag with 3 odd numbers, 3 odds, and the one bag with 3 even numbers. Alright, if one chip is drawn from each bag, and how many different values are possible for the sum of the two numbers on the chips? Alright, so we want to draw one chip from this bag and the one chip from this bag. And then we want to add the two numbers on the chips. Since one is odd and one is even, so we ought to get an odd number. It got to be an odd number. At the same time, we know that the smallest number we can draw from the 3 odds is 1. And the smallest we can draw from the 3 evens is 2. Therefore, the smallest possible sum got to be 3. And the largest number we can draw from the 3 odds is 5. And the largest of the evens are 6. So the largest possible sum is 11. Therefore, we shall get all the possible numbers within this range from 3 to 11. Don't forget, the results got to be an odd number. Therefore, all the possible values are 3, 5, 7, 9, and 11. Those are 5 numbers. So the answer is B. Of course, we can double check all the values. For example, for 5. We can get a 3 from the first bag and a 2 from the second bag. Or maybe you get a 1 from the first bag and get a 4 from the second bag. It doesn't matter, we can get a 5 anyway. However, before we end this problem, I want to make a point in here. In this problem, we want to get how many odd numbers are there within a range from 3 to 11. And I want to introduce a systematic way to do that. We all know that from an integer A, from an integer B, the total number of integers is B minus A plus 1. Of course, we assume B is greater than A. Right? Then for 3 to 11, we know that there are 11 minus 3 plus 1, and that equals to 9 many integers. And we want to know how many odd numbers are there in this range. Therefore, we divide this 9 by 2. This is because how do you find the odd numbers? You find them in pairs with even numbers. Right? 3 and 4 is a pair. 5 and 6 is a pair, and so on and so forth. So altogether, we have the floor of 9 divided by 2 equals to 4 pairs. Right? This is a floor function, which gives you the greatest integer less than this ratio. So this ratio is 4.5. The greatest integer less than that will be 4. So we have 4 pairs. And that's equivalent to 4 odd numbers. And don't forget, we need to check the n numbers, because when we make the pair, right? Let's look at here. When we make the pairs, we have one number that's left. Let's say we start making the pairs from the beginning. So that's one pair, and we have one number left. We need to double check if that leftover is what we want. In here, we want an odd number. Is that an odd? Yes, it is odd. So we have 4 plus 1 many odd numbers within this range. And you can do this in the reverse way. You can make the pairs from the back to the front. Right? That's the same way. And still you have one number left. You need to double check if this is what you want. And the end result is 5. Let's make a small example. Let's say from 31 to, let's make up a random number. Let's say 928. How many odd numbers are there within this range? For 3 to 11, you can count them. That's 3, 5, 7, 9, 11. Right? You know that's 5 odd numbers. But in a much larger range, you can't count them. Then how do you do that? So the way to do it is First, you count the number of integers within this range. That's 9, 28 minus 31 plus 1. So that's 928 minus 30, right? So minus 28, that gives you 900, minus another 2, that gives you 898. That many integers. All right, now let's make the pairs. So how many pairs are there? So that's 898 divided by 2. Since this is an even number, so it is divisible by 2. The result is 449. We have so many pairs. Of course, we have so many odd numbers. And you may wonder, what if we want to find the number of multiples of 3 within this range? How do we get that count? We can do it in the same way. Let's make this example a bit more complicated. How many multiples of 3 within this range? We do the same. We get 928 many integers. And then we need to make the triples, because there's one multiple of 3 in each triple, right? Let's say we start from the beginning. That's one triple, 31, 32, 33, right? And then 34, 35, 36. So we can do the triples. So within 928 many integers, how many triples we have, right? So that equals to 3, 0, 9, and we have a remainder of 1. So we know that there are at least so many triples, of course, at least so many multiples of 3, and we have 1 left over. All right, let's say since we count from the start, the leftover will be 928. Is 928 a multiple of 3? Of course not, we just did the division here. Therefore, we only have 309 multiples of 3 within this range, within the range of 31 to 928. If you like this video, please subscribe and thumb up. If you have questions, please comment.